Now, whatever I have discussed yesterday is on removal and replacement. I will take one small example which is exactly similar to yesterday's class. Probably I will take question number 2 what I have taken in my yesterday's class. I will take second question whatever I have taken in my yesterday's class, so that people who has understood already can recap it. People who has not attended can listen to how you can solve this kind of particular problems, and then we will take forward for today's class. Just hold on for next 2 to 3 minutes for all the people who have attended. Suppose there is a vessel. Assume that initially 100 ml of pure milk is present inside the vessel. Same question I would take, sir. I would take the same question whatever I had discussed yesterday, which was my second question of yesterday's class. 100 ml of pure milk is present inside the vessel. Now, I will take out 10 ml of milk outside the vessel. I will take out 10 ml of milk outside the vessel. I will add 10 ml of water into the vessel. I will take out 10 ml of milk outside the vessel. I will add 10 ml of water into the vessel. Now, when I add water, earlier it was only milk parameter which was present inside the vessel. It was a pure milk. It was a pure milk which is not adulterated. Now, because the added parameter is water and the parameter which was inside the vessel is milk, now it is no more pure milk. It becomes a solution, right? It becomes a solution or a mixture. Now, next thing what I will do is, I will take out 20 ml of solution outside the vessel. I will take out 20 ml of solution. I will add 20 ml of water into the vessel. Next, again, I will take out 30 ml of solution outside the vessel. I will add 30 ml of water into the vessel. And you need to find, your question is, what is the final volume of milk? What is the final volume of milk inside the vessel? Inside the vessel, finally, how much of milk content is present? That is what we need to find. Now, the same kind of question, first question when I took yesterday, I solved it in two methods, method 1 and method 2. But method 1 is very, very evident. If you have attended my yesterday's class, you will be able to understand that method 1 is very, very clearly saying that it is a very, very lengthy method and it's a very time consuming method. And that is the reason we switched on to method 2. And what we call method 2 usually is ANC way of solving. What is this ANC way of solving? I told you one important key point in this method 2. That key point says, always work with the parameter. I am repeating for the people who attended yesterday. I am probably teaching it new for the people who did not attend yesterday. Listen to this carefully, sir. Always work with the parameter which is decreasing. Always work with the parameter which is decreasing. That means there are two parameters in this question. One of the parameter is milk and the other parameter is water. There are two parameters, one is milk and other is water. I need to work with the parameter which is decreasing. Now, out of milk and water, which is the parameter that is decreasing? Milk is the parameter that is decreasing. Why milk is decreasing? Because I am taking milk content outside the vessel. If I am taking milk content outside the vessel, milk parameter inside the vessel will decrease. And that is what I need to work out in this particular problem. That means in this problem, I am actually finding the final volume of milk. I am actually finding the final volume of milk. Always work with the parameter that is decreasing. In this particular question, I am trying to find the final volume of milk. Now listen to this carefully, sir. Initial volume of milk is 100 ml. Write down that 100 ml. Initial volume of milk is 100. Write down that 100 into. Now, people who missed out yesterday's class, listen to this very, very carefully. If you understand it, you will solve the next few questions very easily. Now see here, initially 100 ml of milk is present. Now, what is the first step that I am doing? I am taking out 10 ml of milk. Out of total, how much ml of milk I am taking out? 10 ml of milk. Out of total 100 ml of milk, I am taking out 10 ml of milk. That means I can say that out of total 100, I am taking out 10 ml. That means 10 out of 100 is taken out. 10 out of 100 is taken out, or in other language I can say 1 by 10 is taken out. If 1 by 10 is taken outside the vessel, what is present inside the vessel? Remaining 9 by 10 is present inside the vessel. Remaining 9 by 10 is present inside the vessel. Sir, how it is 9 by 10? Because 1 by 10 plus which number is equal to 1? 1 is nothing but the entire total quantity. 1 by 10 plus 9 by 10 only is nothing but 10 by 10. 10 by 10 is nothing but 1. Or in simple language, I told you easy shortcut yesterday. 1 plus which number is nothing but equal to 10. 1 plus 9 is only 10. That means 1 by 10 is taken outside. 9 by 10 is remaining. I am interested in writing the remaining part. So I will write 9 by 10 here. That means out of 100 I took 10 outside. It became 90. Again I added 10 water inside. It again became 100 at this point. That means after 2 steps are completed, the total volume inside the vessel is 100 ml of mixture right now, because water is also added. Now same logic once again. The next step again remains the same. Now what is the step? 20 ml of solution is taken out. Out of how much 20 ml is taken out? Out of total 100 ml, 20 ml is taken out. First problem only I am explaining in detail, sir. Out of total 100 ml, 20 ml is taken out. 20 out of 100 is taken out. That means 2 by 10 is taken out. That means how much is remaining? 8 by 10 is remaining, because 2 plus which number is equal to 10? 2 plus 8 is equal to 10. That means remaining part inside the vessel is nothing but 8 by 10. Now I took out 20. Again I added 20. Again the total volume became 100 ml. Right? Again the total volume became 100 ml. Next, last thing. 4 steps are completed in this process right now. Last 2 steps. 30 ml of solution is taken out of 100 ml of solution. That means 30 out of 100 is taken out. 3 by 10 is taken out. Remaining is 7 by 10, because 3 plus 7 is only 10. So remaining is 7 by 10. I will write 7 by 10 here. So total quantity of milk finally present is 100 cancels with 100. 9 into 8 into 7. It is 72 into 7. Sorry, 9 into 8 into 7 divided by 10. So it is 504 divided by 10. So it is 50.4 ml. So final quantity of milk present inside the vessel is how much? It is 50.4 ml. I hope whether you are a student who has attended the class yesterday, or whether you are a student who has not attended the class yesterday, after listening to one example today, which is my second question, which I wrote it right now, I believe every student who is listening to the class right now is on the same boat, saying that you have understood the concept right now. I did not solve method 1 in this problem today also, because we know that method 1 is a very time consuming method, which is given in some local textbooks also, and some other institutes also probably might teach it. But we want to learn something which will happen in seconds, and that is what I have taught you in ANC way, in the beautiful way possible. Kindly comment in the live chat if it is clear for everyone, sir. 33 students are watching the class right now as I see in my mobile. I want each of your 30 plus people to comment in the live chat right now and say whether it is clear or not. As Riyaz already said, he has understood it. Kindly comment in the live chat, sir. Kindly comment in the live chat. Before I move on to the 6th question, yesterday I have taken 5 questions in removal and replacement. I will continue from there. Today will be my 6th question. I will start with the 6th question after you people say that it is clear for you people. Now see here. Now listen to this carefully, sir. Now see here. Before moving on to 6th problem of today's, or not today's basically, before moving on to 6th problem of this topic, first let us understand a very small concept. After this concept is clear, we will see how to solve problems using this concept. Listen to this carefully, sir. First, suppose for example, I will take a similar kind of example. There is a vessel. Initial volume is 100 ml of pure milk. This is not a problem for your information. I am taking some numerical values for you and for you to understand the concept. First listen to this. Initial volume is 100 ml of pure milk. I am taking out 10 ml of milk outside the vessel. I am taking out 10 ml of milk outside the vessel, and I am adding 10 ml of water into the vessel. I am taking out 10 ml of milk outside the vessel. I am adding 10 ml of water into the vessel. Now, my question for you is, what is the final volume or the final concentration of milk present inside the vessel? What is the final concentration of milk present inside the vessel? Now, it's a very simple answer for everyone, because only one time I am doing this process. I am taking out milk outside, I am adding water, then I am again not taking the solution outside. So if I take solution outside, you will be confused how much milk is taken out, how much water is taken out, but that is nowhere there in this particular conceptual question. So it's a very easy question. So I can easily say that final volume of milk for this particular question, the answer will be, out of 100 ml of pure milk, I am taking out 10 ml of milk outside. So remaining milk inside the vessel finally is how much? It is 90 ml, right? It is 90 ml. Now think little logically, sir. Before I come back to this concept, if I say 1 by 10 is taken out, remaining will be 9 by 10. How is this 9 by 10? This 9 by 10 is nothing but from total value of 1 unit, I am taking out 1 by 10. 1 minus 1 by 10 is nothing but 9 by 10. Suppose if 2 by 10 is taken out, remaining is 8 by 10. How is that 8 by 10? This 8 by 10 is nothing but from total quantity 1. If I take out 2 by 10, 1 minus 2 by 10 is nothing but 8 by 10, right? 1 minus 2 by 10 is 8 by 10. That means, can I say that final volume of milk in this question is 90, which is 100 minus 10. It is very easy to say like that, but I don't want to tell you like that, because that is a very easy logic only for this easy question, because I am not actually taking out any mixture or the solution outside in this question as of now. That means final volume of milk is 90. That 90, how we used to find? Till now we have solved 5 questions on this removal and replacement. What is the method we used to find for final volume of milk? That we wrote it something like this, called as initial volume is 100. I used to write it 100 multiplied by 10 ml is taken out of 100 ml. That means 10 out of 100 is taken out. 10 out of 100 is taken out. If 10 out of 100 is taken outside, remaining is how much? 1 by 10 is taken outside, remaining is 9 by 10. That 9 by 10 is nothing but 1 minus 1 by 10, or 1 minus 10 by 100. Both are same. I hope I am making sense for you people. I hope I am making sense. That means, can I conclude it like this? Everyone listen to this very carefully, sir. Can I conclude it like this? Can I conclude saying that final volume or the final concentration, final volume is always equal to, what is this 100? First of all, this 90 is nothing but final volume, right? 90 is nothing but final volume. 100 is nothing but initial volume or the initial concentration. Final volume is equal to initial volume into 1 minus, what is this 10? 10 is nothing but how much of solution or the milk content which I am taking out. 1 minus quantity taken out. 1 minus quantity taken outside the vessel. 1 minus quantity taken outside the vessel divided by, what is this 100? 100 is nothing but the total volume. Totally 100 will be there, because I took out 10, again I added 10, again totally it became 100 at this point. I hope I am making sense. That means, very important point. Very important point. Final volume is always equal to initial volume into 1 minus quantity taken out divided by total solution or the total volume. Now this is the logic we use to find the value of final volume of anything, milk or water or whatever it is. But think little logically, sir. Let me go one more step further for your better understanding. Now earlier the process says 10 ml of milk is taken out. I added 10 ml of water. What I will do is, again I will take out 10 ml of solution outside and I will add 10 ml of water. Now Can you tell what will be the next parameter here? What should be written here? We already solved 5 questions in removal and replacement from yesterday, and I revised one more problem in today's session also. What will happen when I take out 10 ml of milk? It became 90. So I added 10 ml of water. It became 100. Now it is no more pure milk. It is solution. I am taking out 10 ml of solution out of 100 ml. 10 out of 100 is taken out once again. That means 1 by 10 is taken out. 10 out of 100 is taken out. 1 by 10 is taken out. Remaining is 9 by 10. How will you get that 9 by 10? 9 by 10 is nothing but 1 minus 1 by 10 or 1 minus 10 by 100. That means, can I say that everyone please understand this very carefully, sir. This is one loop. This is one loop. One loop is nothing but taking outside and putting something inside. That means removing and replacing. That is one cycle or one loop is what we call. 10 ml of milk is taken outside. 10 ml of water is added inside. That is one cycle or one loop. This is first cycle or first loop, whatever it is. This is second cycle, because again 10 ml of solution is taken out, 10 ml of water is added. This is the second cycle or the second loop. That means if I say like this, check it out whether it is right or wrong, sir. If there are 2 cycles or if there is only one cycle, I will write 1 minus 10 by 100 only one time. If I have 2 cycles, I will write 1 minus 10 by 100 or I will multiply 1 minus 10 by 100 2 times. Multiplying the same parameter 2 times is nothing but square. If I have 3 cycles, for example, I will write 1 minus 10 by 100 or I will multiply 1 minus 10 by 100 3 times. That is nothing but cube. If there are n cycles, in general, if there are n cycles, I will multiply 1 minus 10 by 100 n times. That means it is nothing but power n. That means in general I can say that final volume is equal to initial volume into 1 minus quantity taken out divided by total volume whole to the power of n. What is this n representing? N represents the same process is repeated for n times totally. The same process is totally done for n times, or in simple language, totally n cycles or n iterations or n loops are happening in this particular, what do you say, like particular conceptual question, I can say in this case. I hope the idea is very clear. Again I am saying you, sir, final volume is equal to, or final concentration is equal to initial concentration into 1 minus quantity taken out, 1 minus quantity taken out divided by total volume, divided by total volume whole to the power of, if the same process is repeated 2 times, it is power 2, repeated 3 times, it is power 3, repeated 7 times, it is power 7, repeated n times, it is power n. Very beautifully we can derive this concept by using the same problematic questions whatever we have discussed from yesterday's class. 5 questions I have solved already, sir, and I did not even change anything in my conceptual way of problem solving also. This is what we used to solve it every time in the last 5 questions from yesterday's class. Same thing I have done right now also. Instead of directly writing it as 9 by 10, I am writing it as 1 minus 10 by 100. That's the only difference. I hope the idea is very clear for you people, sir. Praveen, good that you asked me that question. This concept is applicable only, or this concept whatever I have derived as final volume is equal to initial volume into something is applicable only if both the parameters are same, both the cycles are same. That means added quantity and removal quantity are same. Sir, what if it is not same? I have already taught you how to solve that yesterday only, right, Praveen? Today also I taught you. That was the first question of today's class. A practice, a revision kind of a question I taught you. That is the reason whatever the question which I have taken here, this particular question, when you whatever you are trying to see here, here it is 10 and 10. but here it is 20 and 20. That means I cannot write 9 by 10 into 9 by 10 into 9 by 10 here. I should write 9 by 10 into some other value depending on the numerical values. What if it differs? It's already thought. It is something which I have already thought. It's something which is not new. Praveen and Neha, is it clear? And good that you both asked the same doubt, because so many people also might have that doubt, and because of you people asking the doubt, many others also will be cleared with that concept.